All right, this is 4.2, estimating area using grids. And as you can see from our diagram here on the right beside try these, you can see we've got a grid like graph paper, and we've got some objects drawn on there. And we want to calculate the area of object A and B, but we don't, because they're an odd shape, we can't get it really exact, but we can estimate it because we've got grid paper on it. So, estimate the area of each shape. A is about how many squares? So what we can do with A is we can count squares. 1, 2, 3, 4, 5, 6, 7, 8, 9. We've got 9 full squares. Okay, so we can start with 9. And then we've got over here, looks like we've got about half a square right there. Here it looks like we have about half a square there, so half and a half is a 1. So we go from 9 to 10. And then over here looks like we've got close to about maybe 3/4 of a square. And then over here we've got a small partial square. So we could probably say that's another 1 or very close to it. So we had 9, these two make 10, and this one here makes 11. So we could say it's about 11 squares. Okay, let's look at B. Well, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 full squares. Okay, so we just put that number 12 beside it. Over here looks like we've got maybe a little bit more than half a square. Over here we look like we've got maybe a little bit more than half a square, close to it, so we could probably add 1 square for those two. This right here is almost a full square, but if we were to add this little bit to it here, that would probably give us 1 full square, so we could add another one, and then we've got the same right here. We almost have a full square there, but we add this little bit right here. We could probably add another square, so 12 plus 1 plus 1 plus 1 is 12, 13, 14, 15, so about 15 squares. Okay, it's not exact, but it's pretty darn close. Okay, so Julian traced around a toonie on a square centimeter grid. 1 square is equal to 1 centimeter squared. Okay, so from here to here is 1 centimeter. And from here to here is 1 centimeter. That's what it means by having 1 centimeter squared. What is the approximate area of the coin? Well, we know we've got 1 full one. So how many whole squares are covered or almost covered? 1, I'd say this is almost covered. 2, this is almost covered. 3, this is almost covered. 4, this is almost covered. 5, so we've got 5 that are almost all covered. Number 2, how many whole squares can be made using squares that are partly covered? Well, I'd say that if we had this here, and we were to add it probably to that there, we would end up with really close to 1. And then if we were to take that and add it to this part right here, we'd be really close to another 1. So I'd say probably 2. Again, this isn't exact, it's just approximate. That's why we use the word about or almost. Estimate the total area of a toonie, about 7 centimeters squared. Okay, we just added 5 and 2. Example. What is the approximate, we're using the word approximate here, again it's not exact, what is the approximate area of the footprint on the grid? 1 square represents 1 square inch. Okay, solution. How many whole squares are covered or almost covered? Okay, well, you know, we can probably say that we have a whole square covered right there. We have a whole square covered right there, covered right there. We've got another one covered right there, another one covered right there, and right there. Probably this one is fairly close to being covered. Same with that one there. Okay. We've got another one maybe right there. We got one there for sure. This one's really close. This one for sure. This one for sure. Looks like we got another one there, another one there, another one there, another one there, and maybe one right here. One really close to there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. I count 20. 20 squares or close to almost fully being covered. How many whole squares can be made using squares that are partly covered? Okay, well here looks like we've got about a half of one. Okay, here another half of one, so those two there could be 1. We've got about half of one here and about half of one there, so those two will make another one. This is probably pretty close to half, and this is probably fairly close to half here, so we can do another one. So there's 3 right there. Okay, so I'm just going to write the number 3 plus. Then we've got a little bit right here and a little bit right here, and maybe a little bit. Oh, let's see. Maybe a little bit right here. So between that, and that, we can get another one. Okay. Probably have one there, one there. Those 2 right there will probably give us another one. Okay, so you see how we kind of do this? There's a little part right there. And that's probably about all we can get. Maybe we'll add one more. So we got 3, 4, 5, 6. So about 6 partial squares filled. So we could probably say that when we're estimating the area, 20 plus 6 is about 25 to 26 square inches, or inches squared. Okay, that's just by estimating. Why do you think it's necessary to consider very small bits and partial squares? Or do you think it's necessary to consider very small bits and partial squares? Well, if we're estimating and we've got a whole bunch of partial bits, you can add them up maybe, to form one. But, if they're really tiny and small, it's not really that necessary to do it. Okay, because we're getting an approximate measurement here. Okay, we're not getting an exact measurement. All right, so that's about all you need to know to estimate area using grids. So make sure you get some grid paper from your teacher, or you can make your own grid or graph paper. Rip it out of your book somewhere. You got some in the back of your book. You can use that to lay over top like tracing paper of an object, and then you can do some estimating and some guessing as to how big an area is. Okay, so start working on the practice.